Class 1 Division 2 location is an area where flammable gases, vapors, or liquids are present but are normally confined within closed containers or closed systems from which they can escape only through accidental rupture or breakdown of these containers or systems, or in the event of abnormal operation of equipment. The boundary of a Class 1 Division 2 location typically extends 15 feet in all directions from the potential source of the flammable material. This 15-foot radius defines the area within which electrical equipment must be suitable for use in a Class 1 Division 2 environment, meaning it must be designed to prevent ignition of the flammable materials that may be present. To more precisely define the boundaries of a Class 1 Division 2 location, several factors must be considered. Firstly, the specific properties of the flammable material involved, including its vapor density flash point and auto-ignition temperature, play a crucial role. Heavier than air vapors will tend to accumulate near the ground, extending the hazardous area horizontally, while lighter than air gases will dissipate more quickly. Secondly, the ventilation conditions in the area significantly impact the dispersion of flammable materials. Adequate ventilation can reduce the extent of the hazardous area by diluting the concentration of flammable vapors or gases. Conversely, poor ventilation can lead to accumulation and expansion of the hazardous area. Thirdly, the presence of physical barriers, such as walls or partitions, can restrict the spread of flammable materials and reduce the size of the Class 1 Division 2 location. These barriers can act as a containment measure, preventing the migration of vapors or gases to adjacent areas. Fourthly, the frequency and duration of potential releases of flammable materials are important considerations. If releases are infrequent and of short duration, the extent of the hazardous area may be smaller. However, if releases are more frequent or prolonged, the hazardous area may need to be larger to account for the increased risk of ignition. Fifthly, the specific equipment and processes involved in the handling of flammable materials must be evaluated. Equipment that is prone to leaks or spills will increase the risk of a hazardous atmosphere, requiring a larger Class 1 Division 2 area. Sixthly, the applicable codes and standards, such as the National Electrical Code, or NEC, and other relevant industry standards, provide guidance on determining the appropriate boundaries for Class 1 Division 2 locations. These codes and standards outline the requirements for electrical equipment and wiring in hazardous locations, including the use of explosion-proof enclosures, intrinsically safe circuits, and other safety measures. Seventhly, a qualified professional, such as a certified hazardous location consultant or a professional engineer with expertise in hazardous area classification, should be involved in determining the boundaries of a Class 1 Division 2 location. This professional can conduct a thorough assessment of the area, taking into account all of the relevant factors, and provide recommendations on the appropriate classification and extent of the hazardous area. Eighthly, documentation of the hazardous area classification and boundaries is essential. This documentation should include a detailed description of the area, a list of the flammable materials present, a map showing the extent of the Class 1 Division 2 location, and a summary of the factors considered in the classification process. Ninthly, regular reviews and updates of the hazardous area classification are necessary to ensure that it remains accurate and appropriate. Changes in equipment, processes, or the properties of flammable materials can affect the extent of the hazardous area, requiring adjustments to the classification and boundaries. Tenthly, training of personnel who work in or near Class 1 Division 2 locations is crucial. These personnel should be aware of the hazards associated with flammable materials, the boundaries of the hazardous area, and the safety procedures that must be followed to prevent ignition. The use of appropriate personal protective equipment, or PPE, is also important. Electrical equipment in Class 1 Division 2 locations must be suitable for the environment. This often means using equipment listed or labeled for Class 1 Division 2 locations. Explosion-proof enclosures are a common method of protection. These enclosures are designed to contain an internal explosion and prevent it from igniting the surrounding atmosphere. Intrinsically safe circuits are another method of protection. These circuits are designed to limit the energy available so that it is below the level required to ignite a flammable atmosphere. Purged and pressurized systems can also be used. These systems use positive pressure to keep flammable materials out of electrical enclosures. Wiring methods in Class 1 Division 2 locations must also comply with specific requirements. Conduit and cable must be properly sealed to prevent the migration of flammable vapors or gases. Fittings and boxes must be listed for use in Class 1 Division 2 locations. Proper grounding and bonding are essential to prevent the buildup of static electricity, which can be a source of ignition. Regular inspections and maintenance of electrical equipment in Class 1 Division 2 locations are critical. These inspections should include checks for damage, corrosion, and loose connections. Any deficiencies must be promptly corrected to maintain the safety of the area. The area extending 15 feet from a potential source is a general guideline. A detailed hazard assessment should always be performed by qualified personnel to accurately determine the boundaries of the Class 1 Division 2 location. Remember, safety is paramount when working with flammable materials. Following established codes, standards, and best practices will help to prevent accidents and ensure a safe working environment. When performing a hazardous area classification, it's vital to consider several key aspects. Firstly, identify all potential sources of release. This involves pinpointing equipment or processes where flammable substances might escape under normal or abnormal conditions. Examples include storage tanks, piping systems, valves, pumps, and open containers. Secondly, determine the properties of the flammable substances. Understanding the characteristics of the materials, such as their flash point, auto-ignition temperature, vapor density, and explosive limits, is crucial. This information is typically available in the Materials Safety Datasheets, or MSDS. Thirdly, evaluate the ventilation conditions. Assess the natural and mechanical ventilation systems in the area. Good ventilation can dilute and disperse flammable vapors, reducing the extent of the hazardous area. Factors to consider include the air exchange rate, the location of ventilation inlets and outlets, and the presence of obstructions that might impede airflow. Fourthly, consider the frequency and duration of releases. Estimate how often releases are likely to occur and how long they might last. This will help determine the probability of a flammable atmosphere being present. Infrequent, short-duration releases might justify a smaller hazardous area compared to frequent, prolonged releases. Fifthly, assess the potential for accumulation. Evaluate whether flammable vapors or gases are likely to accumulate in certain areas due to poor ventilation or physical obstructions. This can create pockets of higher concentration, extending the hazardous area. Sixthly, identify potential ignition sources. Determine the presence of any equipment or activities that could ignite a flammable atmosphere. This includes electrical equipment, open flames, hot surfaces, welding operations, and static electricity. Seventhly, consider the presence of barriers. Evaluate whether any physical barriers, such as walls, partitions, or enclosures, can limit the spread of flammable vapors or gases. Barriers can reduce the extent of the hazardous area by preventing the migration of flammable substances to adjacent areas. Eighthly, determine the appropriate classification. Based on the above factors, classify the area according to the National Electrical Code, or NEC, or other applicable standards. This will determine the type of equipment and wiring methods required for the hazardous area. Ninthly, document the classification. Prepare a detailed written report that documents the classification process, including all assumptions, calculations, and justifications. This report should be reviewed and approved by a qualified professional. Tenthly, review and update the classification. Regularly review and update the classification as conditions change, such as modifications to equipment, processes, or ventilation systems. This will ensure that the classification remains accurate and appropriate. The 15-foot radius is a general guideline that may need to be adjusted based on the specific circumstances of the location. Consultation with a qualified professional is recommended to ensure that the hazardous area is properly classified and that appropriate safety measures are implemented. Remember to always prioritize safety when working with flammable materials. Adherence to codes, standards, and best practices is essential to prevent accidents and protect personnel. Proper training and awareness are also crucial for ensuring a safe working environment. Continuous monitoring and maintenance of equipment and systems are necessary to prevent releases and maintain the integrity of the hazardous area classification. In addition to the 15-foot rule of thumb, it's crucial to understand the different zones within a Class 1 Division 2 location. While the entire area is considered hazardous, the probability of a flammable atmosphere being present varies depending on the proximity to the source of release. Areas closer to the source are generally considered to have a higher probability of a flammable atmosphere, while areas further away have a lower probability. This variation in probability can influence the type of equipment and wiring methods required in different parts of the Class 1 Division 2 location. For example, equipment located directly adjacent to a potential source of release may require a higher level of protection, such as explosion-proof enclosures, while equipment located further away may be suitable with a lower level of protection, such as intrinsically safe circuits. The determination of these zones within a Class 1 Division 2 location should be based on a thorough hazard assessment that considers the factors previously discussed, including the properties of the flammable material, the ventilation conditions, and the frequency and duration of releases. The assessment should also take into account the potential for accumulation of flammable vapors or gases, as well as the presence of any barriers that might limit the spread of the hazardous atmosphere. It's important to note that the boundaries of these zones are not always clearly defined and may require the judgment of a qualified professional. The professional should use their expertise and experience to determine the appropriate boundaries based on the specific circumstances of the location. In addition to the zoning considerations, it's also important to understand the different types of equipment that are suitable for use in Class 1 Division 2 locations. As mentioned earlier, explosion-proof enclosures are a common method of protection. These enclosures are designed to contain an internal explosion and prevent it from igniting the surrounding atmosphere. Intrinsically safe circuits are another method of protection. These circuits are designed to limit the energy available so that it is below the level required to ignite a flammable atmosphere. Purged and pressurized systems can also be used. These systems use positive pressure to keep flammable materials out of electrical enclosures. Non-incendive equipment is another type of equipment that is suitable for use in Class 1 Division 2 locations. Non-incendive equipment is designed so that it will not cause ignition under normal operating conditions. However, non-incendive equipment is not suitable for use in areas where a flammable atmosphere is likely to be present continuously or for long periods of time. The selection of the appropriate type of equipment for a Class 1 Division 2 location should be based on a careful consideration of the potential hazards and the requirements of the applicable codes and standards. It's also important to ensure that the equipment is properly installed and maintained in accordance with the manufacturer's instructions. Regular inspections and maintenance are essential to ensure that the equipment continues to provide the intended level of protection. In addition to the technical aspects of Class 1 Division 2 locations, it's also important to consider the human factors involved. Training and awareness are crucial for ensuring that personnel who work in or near these locations are aware of the hazards and know how to work safely. Training should cover topics such as the properties of flammable materials, the hazards of ignition, the proper use of equipment, and emergency procedures. Personnel should also be trained to recognize the signs of a potential release and to take appropriate action to prevent accident. Awareness programs can help to keep personnel informed of the latest safety information and to reinforce safe work practices. These programs can include toolbox talks, safety meetings, and posters. It's also important to encourage personnel to report any safety concerns or near misses. This can help to identify potential hazards and prevent accidents before they occur. A strong safety culture is essential for ensuring a safe working environment in Class 1 Division 2 locations. This culture should be based on a commitment to safety at all levels of the organization, from management to frontline workers. Safety should be a priority in all decisions and actions. Continuous improvement is also essential. The safety program should be regularly reviewed and updated to reflect the latest knowledge and best practices. By considering all of these factors, it is possible to create a safe and productive working environment in Class 1 Division 2 locations. Remember, safety is everyone's responsibility. By working together, we can prevent accidents and protect our personnel. In summary, determining the boundaries of a Class 1 Division 2 location involves a comprehensive assessment of various factors, including the properties of the flammable material, ventilation conditions, frequency and duration of releases, potential for accumulation, presence of ignition sources, and the existence of barriers. While the 15-foot rule provides a general guideline, a detailed hazard assessment conducted by qualified professionals is crucial for accurately defining the hazardous area and ensuring the implementation of appropriate safety measures. Ongoing training, awareness programs, and a strong safety culture are essential for maintaining a safe working environment in Class 1 Division 2 locations. The 15-foot guideline should be considered a starting point for evaluation and not a definitive boundary without further analysis. The ultimate goal is to protect personnel and equipment from the hazards associated with flammable materials. Remember that local codes and regulations may have specific requirements that must be followed in addition to the general guidelines discussed here. Always consult with local authorities and qualified professionals to ensure compliance with all applicable regulations. And most importantly, never compromise on safety. The potential consequences of an accident in a Class 1 Division 2 location can be severe, so it's essential to take all necessary precautions to prevent them. In the context of electrical installations within a Class 1 Division 2 environment, several key considerations must be addressed to ensure safety and compliance. Firstly, electrical equipment selected for use must be specifically rated and approved for Class 1 Division 2 locations. This rating signifies that the equipment has been designed and tested to prevent ignition of flammable vapors or gases that may be present. Such equipment typically includes features like explosion-proof enclosures, which are designed to contain any internal explosions and prevent them from propagating to the surrounding atmosphere. Secondly, wiring methods must adhere to stringent requirements to minimize the risk of ignition. This often involves the use of sealed conduit systems to prevent the ingress of flammable substances. Additionally, special fittings and seals are employed to maintain the integrity of the wiring system and prevent the escape of any potential sparks or arcs. Thirdly, grounding and bonding practices are critical to eliminate static electricity buildup, which can serve as an ignition source. Proper grounding ensures that any static charges are safely dissipated, reducing the likelihood of sparks that could ignite flammable vapors or gases. Fourthly, regular inspections and maintenance are essential to identify and address any potential issues before they escalate into hazardous situations. Inspections should include checks for damaged equipment, loose connections, and any signs of corrosion or deterioration. Prompt repairs and replacements are crucial to maintain the safety and integrity of the electrical installation. Fifthly, personnel working in Class 1 Division 2 locations must receive comprehensive training on the specific hazards present and the appropriate safety procedures to follow. This training should cover topics such as the properties of flammable materials, the potential sources of ignition, and the correct use of personal protective equipment, or PPE. Sixthly, lockout/tagout procedures should be strictly enforced during any maintenance or repair work on electrical equipment. These procedures ensure that equipment is de-energized and isolated before any work begins, preventing accidental energization and potential ignition of flammable substances. Seventhly, emergency shutdown systems should be readily accessible and properly maintained. These systems allow for the rapid de-energization of electrical equipment in the event of a fire or other emergency, minimizing the potential for escalation and further damage. Eighthly, hot work permits should be required for any activities that could generate sparks or heat, such as welding or cutting. These permits ensure that proper precautions are taken to prevent ignition of flammable vapors or gases, such as ventilation and monitoring of the atmosphere. Ninthly, portable electrical equipment should be kept to a minimum and must be specifically approved for use in Class 1 Division 2 locations. This includes items such as extension cords, power tools, and lighting equipment. Tenthly, signage should be prominently displayed to warn personnel of the hazards present and the necessary precautions to take. This signage should be clear, concise, and easily understood by all personnel working in the area. By adhering to these electrical safety considerations, the risk of ignition in Class 1 Division 2 locations can be significantly reduced, creating a safer working environment for all personnel. The NEC Article 500 provides detailed guidance on the requirements for electrical equipment and wiring in hazardous locations, including Class 1 Division 2 areas. It's essential to consult this article and other relevant codes and standards to ensure compliance and maintain a safe working environment. The 15-foot boundary is not a fixed dimension. Always refer to qualified professionals and safety experts for a precise area hazard assessment.